Welcome back to Tungal College online classes. Hello students, how are you all? In last class you learned energy level diagram for molecular orbitals, the molecules with less than 14 electrons. And today we have the continuation topic, energy level diagram for the molecular orbitals, the molecules with less than 14 electrons and molecules with greater than 14 electrons. So first we will discuss about the molecules with less than 14 electrons. In that one important molecule is that molecule is N2 molecule. N2 molecule, in PUC examination point of view, the N2 molecule is very important. N2 molecule is very important for exam. So the N2 molecule, first what you have to do to construct the molecular orbital energy level diagram for the molecular orbitals. First we have to write electronic configuration of these atoms. So nitrogen 7, its electronic configuration is 1s2, 2s2, 2p3. One nitrogen. There are two nitrogens. For this nitrogen also we have to write same electron configuration, 1s2, 2s2 and this is 2p3. Clear. Then we have to arrange these electronic configurations from bottom to top. So first I am taking one nitrogen here. This is one nitrogen. This nitrogen I took here and another nitrogen I am taking here. This is the another nitrogen. Then what we have to do? We have to arrange electron configuration from bottom to top. Then first I am taking here is 1s2. Then this is 2s2. Then this I am labeling here is 2p3. 1s2, 2s2, 2p3. I arrange 1s2, 2s2, 2p3 for one nitrogen. Second nitrogen same, right? You can write 1s2, 2s2. This is 2p3. Clear. Then you can take a orbital diagram for this 1s2 orbital. So this is the orbital diagram. For this 1s orbital, this is orbital diagram. Right, these atomic orbital combined with this atomic orbital. So both atomic orbital combine to form molecular orbital. Right, we will get two molecular orbitals. One is called as bonding molecular orbital. Another one is anti-bonding molecular orbital. One is bonding, another one is anti-bonding. This will be labeled as what? Sigma. What is this? 1s. This is sigma 1s. What is this? Anti-bonding. Up one is anti-bonding. This is sigma star 1s. Bottom one is bonding. Bonding molecular orbital. So top one we have to call as anti-bonding molecular orbital. So this one is completed. Then coming to the second one, 2s2 orbital. So I am writing its orbital diagram. For this case also I am writing its orbital diagram. This one is 2s2 orbital and this 2s2 orbital combines to form molecular orbitals. Two are combining, you will get how many? 2. Right, this is one bonding molecular orbital and this is another anti-bonding molecular orbital. We have to label it. Bonding is sigma. What is this orbital? 2s. Sigma 2s. This is what? Anti-bonding. Anti-bonding will be represented by sigma star. What is this? 2s. This one is completed. Then coming to the 2p3 orbital. So how many p orbitals we have? Total 3 p orbitals. 1, 2, 3. So 1, 2, 3, px, py and pz. For this case also we have how many p orbitals? 3 p orbitals. 1, 2 and 3. px, py, pz. So this 3 p orbital, this 3 p orbital. Total how many we have? 6 p orbital. 6 combined will produce 6 molecular orbitals. 6 atomic orbitals are combining produce 6 molecular orbitals. Here 2 is combined, 2 is formed. Here 6 is combining, 6 must be get formed. Then let us write them. So first 3 I am writing here, 2 I am writing here bottom. Here is 2, here is 1. So these 3 are a bonding molecular orbital. And top we have to write 3. Here is 2 and here is the 1. These are anti-bonding molecular orbitals. For this case we have to label it. This is pi 2px. This is pi 2py. This is sigma 2pz. Pi 2px, pi 2py, sigma 2pz. Then for this case pi star, these are anti-bonding. Anti-bonding, this will become pi star 2px. This is pi star 2py. Pi star 2px, pi star 2py. This is sigma 2pz will become sigma star 2pz. Sigma star 2pz. So we constructed the energy level diagram for N2 molecule. Then what we have to do is we have to fill with the electrons. Then here is how many electrons is there? 2 electrons. 1, 2. I filled in atomic capital. Here is how many electrons? 2 electrons. 1, 2. Right? 2 plus 2 total 4 electrons. These 4 electrons we have to fill in molecular capital. This is atomic capital. This is atomic capital. We'll get here is a molecular capital. So 2 plus 2 4. Then first we have to fill lower energy. This is the lower energy. Energy order. Energy order. From bottom to top energy is going to get increases. This is the lower energy and this is the higher energy. Bonding is lower energy, anti-bonding is higher energy. How many electrons is it? 2 plus 2 4. First 1, 2. This is completely filled. Then we have to go to anti-bonding. 3, 4. So 2 plus 2 4 we filled in the water. This is completed. Then coming to this one. 2s2, there are 2 electrons, 1, 2. Here also 2 electrons, 1, 2. Then total number of electrons, 1, 2, 3, 4. First we have to fill in bonding, 1, 2. Each box maximum contain 2 electrons only, 2 is maximum, so filled. Then go to the next one, 3, 4. So this case also electrons are filled. Then coming to the 2p3, how many electrons is there? 1, 2, 3. 1, 2, 3. Here also 1, 2, 3. Total number of electrons 1, 2, 3, 4, 5, 6 electrons. We have to fill these 6 electrons in the bonding and anti-bonding. How we can? So I'm taking first we have to fill the pi 2px because this is the lower energy 1 and these two are the same energy. Then we have to fill in this case 1, 2, then 3, 4. So this is completely filled. This is completely. After completion we have to go to 2pz. 1, 2, 3, 4, 5, 6. So sufficient to 6 electron. If 7th electron is there, we have to fill here. 7 electrons is not there, so that we have to fill in the only bonding molecular orbital. So this is the filling of electrons in a bonding and anti-bonding molecular orbitals in N2 molecule. So we filled electrons in also. Then what we have to do? We have to write 3 points. The first one is electronic configuration. Electronic configuration. Electronic configuration of N2 molecule. N2 molecule. So how do we write? Simply we have to arrange these orbital from lower energy state to higher energy. First we have to take a lower energy, then we have to take next higher energy, next energy. So bottom to top we have to write. Simply we can arrange from these atomic orbitals bonding and anti-bonding from lower energies to higher energy. That is the answer. So first we have to take sigma 1s. Sigma 1s. How many electrons is there? Sigma 1s 2 electrons. Sigma 1s2 is less than, energy is increasing order, energy this is less than this one, less than sigma star 1s. Sigma star 1s. How many electrons is there? 1, 2 electrons. 2 less than, next what we have to write? Sigma 2s. Sigma 2s. How many electrons is there? 1, 2. Sigma 2s2 is less than, next what we have? Sigma star 2s. Sigma star 2s. How many electrons is there? 1, 2 is less than, then what we have? Pi 2px, pi 2p both are side by side. So their energies are same. Then we have to write pi 2px. In pi 2px how many is there? 1, 2 electrons. 2 that is equal to pi 2py. How many electrons is there? Again 2 is there. 2. This one completed. Less than. Then what we have? Sigma 2pz. Sigma 2pz. How many electrons is there? In sigma 2pz? 1, 2. 1, 2. Next what we have? Pi 2px, pi 2p, pi sigma star 2pz. In this case electrons are not there. If electrons are not there, no need to write in a electronic configuration. This is the electronic configuration of N2 molecule. Then the second one what we have to do is we have to find out bond order. Bond order of N2 molecule. What is the formula for bond order? Bond order By is equal to half into number of electrons in bonding minus number of electrons in anti-bonding. This is the formula we have. Number of electrons in bonding minus number of electrons in anti-bonding. Then we have to count it. That is equal to half into number of electrons in bonding. This is the bonding. This is bonding. How many number of electrons is there? 2. This is anti-bonding. But in this diagram, bottom one is the bonding, top one is anti-bonding. In this diagram, bottom is bonding, top is anti-bonding. In this diagram, bottom, these three are the bonding, these three are the anti-bonding. Bottom, in each diagram, bottom one are the bonding, above one is the top one is the anti-bonding. So here is the 2 electrons. 2. This in this case, in this diagram, here is the 2 electrons bonding. So I am labeling it, rounding it. So these are the bonding, these are the bonding. And in this diagram, these are the bonding. These are the bonding. How many electrons total? 2 plus 2, 4. 4 plus 2, 6. This 2, 8. And here is 2. Total 10. So here is 2 plus 2, 4 plus these are 6. Total 10. Bonding is 10 minus. Now count the electrons in anti-bonding. How many is there? This is the anti-bonding. 2 electrons. Here is anti-bonding. 2 plus 2, 4. But here is no electrons in the anti-bonding. There is no electrons, no need to take it. So 2 plus 2, total we have 4. So 10 minus 4. That is equal to half into, this is how much? 6. That is equal to 3. This indicates what? In nitrogen molecule, between the 2 nitrogen atoms, triple bond is present. Bond order is how much we got? 3. 3 indicates that N triple bond N. N triple bond 1. Bond order meaning nothing but what? Number of bonds between 2 atoms. Bond order meaning is number of bonds between 2 atoms. That is bond order. How many number of bonds is there? 1, 2, 3. So 3 bonds we are getting bond order is 3. So N2 molecule bond order is equal to 3. That is how do you get now half into number of electrons in the bonding minus number of electrons in anti-bonding. That's completed. Then third one. What is the third one? Magnetic nature. Magnetic nature of N2 molecule. So there are 2 categories. It may be diamagnetic or paramagnetic. We have to find out. So what is the magnetic nature of this N2 molecule? Look at this. 1, 2 electrons fully. So orbital box with 2 electrons like this. This is the diamagnetic. Paired. Double 2 electrons will be there. If orbital box is only 1 electron is there. Singly occupied. Singly occupied is para. Singly occupied is para, doubly occupied is dia. So this is doubly occupied. Here is 2 electrons, doubly occupied. Here is 2 electrons. Here is the 2. Here is the 2. To each box has 2 electrons. No single electron like this. So all molecular orbitals are doubly occupied. Indicates that N2 molecule is diamagnetic. Diamagnetic nature. So this is a molecular orbital energy level diagram and electron configuration, bond order and magnetic nature of N2 molecule. Sometimes they will ask construction of molecular energy level diagram for energy level diagram for molecular orbitals of N2 molecule. Otherwise directly they will ask write the electronic configuration of N2 molecule or write the bond order of N2 molecule or directly what is the magnetic nature of N2 molecule. So many possibilities is there. This question is very important to learn properly. So this is molecular energy level diagram for molecular orbitals of N2 molecule. Next topic, energy level diagram for molecular orbitals, the molecules with greater than 14 electrons. Example is O2 molecule. Example is O2 molecule. And PUC point of view, the O2 molecule also is very important. O2 molecule. And first what we have to do? We have to take a electronic configuration of 2 oxygen atom. Electronic configuration 1s2. Oxygen is atomic number 8, 1s2, 2s2, 2p4. And another oxygen, it also atomic number 8, same configuration 1s2, 2s2, 2p4. Then what is our next thing? We have to take these atoms here. We have to arrange electronic configurations from bottom to top. So first I am taking one oxygen here. and I'm taking another oxygen here. Right, I'm writing this electron configuration from bottom to top. The first one what we have is 1s2, then we have 2s2, then we have 2p4. Next, for this case, another oxygen 1s2, 2s2, this is 2p4. This oxygen, one oxygen I wrote here, another oxygen I wrote an electron configuration from bottom to top. Then we have to take orbital diagrams. 1s2 orbital diagram is this one, and this 1s2 orbital diagram is this one. These atomic orbitals combine to form molecular orbitals. How many they are combining? 1, and this is second one. 2 combining, will get 2 molecular orbitals. Right, one is bonding, another one is anti-bonding. Right, for this case, this is the molecular orbital diagram for 2s2 orbital, this orbital diagram for this case. Then these two will be combined. This is the for 2s case. So one is bonding and another one is anti-bonding. I got 2. Then coming to the 2p4, the total number of electrons in the 2p4 we have take is, number of boxes in the 2p4 is, p orbital is only 3, px, py, pz. For this case also 2p4 case, 2p case, px, py, pz. So 1, 2, 3, 4, 5, 6, total 6 is combining. So how many will get? 6 molecular orbitals. I am representing them right now. Right, 6 combined, total get how many? 6. So here I am taking 1, here I am taking 2. This is opposite to N2 molecule. In N2 molecule, here we took 2, here we took 1. Opposite we have taken, this is greater than 14 electrons. So look at here, oxygen is, each oxygen atomic number is 8 and another oxygen is 8. The total number of electrons, one oxygen is 8 electrons. Plus another oxygen is 8 electrons, 8 and 18, 16 electrons. The value is greater than 14. In the case of nitrogen, each nitrogen is 7, 7 plus 7, 14. So equal to 14, less than 14 or equal to 14. In that case, we have to take these two boxes down, this box is up. That is the only difference. Remaining diagrams, concept, everything will be the same. This is the only difference. So this one we have to take, in the case of N2, these two boxes we wrote down, this box we wrote upside. And in this case, what we are taking is boxes, the two boxes down, 2px, 2py is an upside, 2 sigma 2pz is at the bottom side. I am repeating, pi 2px, pi 2py I am writing top side, sigma 2pz I am writing bottom. That is the difference between N to 14 electron system, less than 14, equal to or less than 14 electron system, and greater than 14 electron system. Right, next, here this remains the same, 2 electrons. Here is the, this is the 2 boxes here, here is the 2 boxes. Here is the 1 box completed. Then next, we have to label these orbitals. This is 1s, sigma 1s. This is what? Sigma star 1s. This is what? Sigma 2s, isn't it? Sigma 2s, sigma 2s. This is a top one, sigma star 2s. This is what? Sigma 2p z orbital. This is what? Pi 2pz. So pi 2px, pi 2py orbital. This is what? Pi star anti-bonding, pi star 2px. So this is what? Pi star 2py. This is sigma star 2pz. Completed. Then after labeling these molecular orbitals, we have to fill with electrons. So this is the first one. Here is 2 electrons. Here is the 2 electrons. The total number of electrons is 1, 2, 3, 4. Then we have to fill in molecular orbital 1, 2, 3, 4. Completed this one. And here is 2s2, 2s2. Total number of electrons is 4. So 1, 2, 3, 4. And we have to fill in the molecular orbitals 1, 2, 3, 4. I am repeating, this is atomic orbital, this is also a atomic orbital. Atomic orbitals we have to filling in, middle orbitals are called nothing but molecular orbital. Atomic orbital combined with atomic orbital to form molecular orbital. So we have to fill electrons in molecular orbitals. Then here is this completed. This here is how many? 4 electrons. 1, 2, 3, 4. I am taking 4. So 1, 2, 3, 4. I took 4 here. Right, 1, 2, 3, 4, 5, 6, 7, 8, total 8 electrons. Then 1, 2, this completed. 3, 4, 5, 6. Then we have to go to here, anti-bonding. 7, 8. 7 and 8. So we filled the electrons. So this is a increasing order of energy. Increasing order of energy. So this is the construction of molecular energy level diagram for molecular orbital of En2. Construction completed. Then we have to write what? First is electronic configuration. Electronic configuration of O2. Of O2. How to write? We can arrange these molecular orbitals from bottom to top. First what we have? Sigma 1s. Sigma 1s, how many number of electrons is there? 2. So sigma 1s2. Then this case less than sigma 1s, sigma star 1s, how many electrons is there? 2. Is less than, isn't it? Then sigma 2s. Sigma 2s, how many electrons is there? 2 there also. Then sigma star 2s. How many electrons is there? Again 2. I am talking about this one. 2 electrons is there. Less than. Then what we have? Sigma 2pz. Sigma 2pz. How many electrons is there? 2. 2. Less than. Then what we have? Pi 2px, pi 2p. Each contains 2 electrons. Pi 2px contain 2 electrons. Pi 2py 2. Here also 2 electrons. Both are equal. Isn't it? Less than. Less than. What next we have? Pi star 2px, pi star 2py. Pi star 2px. How many electrons is there? Only 1 electron is there. Equal to pi star 2py. How many electrons is there? Only 1 electron. Isn't it? So I am rewriting that one. This one is less than. This one I am writing pi star 2px is equal to pi star 2py1. This is a electronic configuration of O2 molecule. Simply what I did, I arranged these orbitals, molecular orbitals from bottom to top. First we will take this one, these electrons, take this one, these electrons, take this one, these electrons, we filled. So this is a very simple thing. Then second one is a bond order. The second one is bond order, BO is equal to what is the formula? Half into number of electrons in the bonding minus number of electrons in anti-bonding, isn't it? Then that is equal to half into number of electrons in the bonding. B represents bonding, A represents anti-bonding. Bonding. So this is the bonding, 2 electrons. In these two, this is the bonding. Bottom one is the bonding. These two, this is the bottom one is the bonding. The total number of electrons. 2 plus 2, 4. 4 plus this, how many is there? 6 is here. So 1, 2, 3, 4, 5, 6. This 6 plus 2 plus 2, total 10 is total 6, 2 plus 2, 4, 4 plus 6, 10. Total is 10. 10 minus anti-bonding. This is anti-bonding. This is bonding, this is anti-bonding. How many? 2. This is anti-bonding. 2 plus 2, 4. Here is 2, here is 2, 4. And here is, this is the anti-bonding. In anti-bonding, how many is there? 1, 2 electrons. So 2 plus 2, 4 plus 2, 6. So 10 minus 6. Isn't it? That is equal to, how much will get? 4 by 2. 4 by 2 in the sense that is equal to 2. This indicates what? The bond order 2 indicates what? Between the two oxygen atoms, how many number of bonds? O double bond O. This bonded to indicates between the two oxygen atoms there is a double bond. There is a double bond between two oxygen atoms. Already I said bonded meaning is number of bonds between the two atoms. Then third one, magnetic nature. Magnetic nature. What we can expect the magnetic nature of O2 molecule? I already said 2 electrons is there. This is we have to call as dia. Doubly occupied. Only one electron is there. We have to call it as a para. So this is 2 electrons doubly occupied. Here also doubly occupied. Doubly occupied. Here is 2 electrons doubly occupied. All these doubly occupied. Look at here. This orbital has a single electron. This orbital has a single electron. At least one orbital has single electron. That substance is a paramagnetic substances. So this oxygen molecule has a single occupied electrons in orbitals, molecular orbitals. So this is a paramagnetic nature. So this is a construction and electronic configuration, bond order and magnetic nature of O2 molecule. So any system greater than 14 electrons, greater than 14, we have to follow same system. So we can take electronic conversions, we can arrange like this, construct the molecular orbitals like this, energy level diagram like this, and you can write electronic conversion, bond order and magnetic nature. Any other molecules which greater than 14, we have to follow this system only. Any molecule with less than 14 or equal to 14, we have to follow nitrogen. Next topic is hydrogen bonding. The hydrogen bonding is defined as the attractive force developed between hydrogen atom of one molecule and more electronegative atom of another molecule is called as hydrogen bonding. So what is the meaning of this statement? Let us understand by taking an example. I am taking HF molecule. So here is fluorine is more electronegative atom, so that the fluorine will get partially negative charge, hydrogen will get partially positive charge. I am taking another molecule, HF. So this is partially negative, hydrogen is partially positive. I am taking another one, so HF. This is partially positive, this is partially negative. And I am taking another one, HF. This is the partially positive, fluorine is partially negative. So like that we can arrange many number of molecules. Now come to the point. This molecule, fluorine has the partial negative charge. In this molecule, hydrogen atom has the partially positive charge. So negative, positive, partial negative, partial positive. In between them, attractive force is developed. This attractive force I am showing like this. This one we have to call as a hydrogen bond. Hydrogen bond. So the attractive force developed between hydrogen atom of one molecule and more electronegative atom of another molecule is called as a hydrogen bond. So coming to these two molecules, this is one molecule, this is another molecule, this is more electronegative atom and this is the hydrogen of another molecule. Between them there is a hydrogen bond. So this is the hydrogen bond. Between these two molecules, fluorine is more electronegative, hydrogen is this partial negative charge, this is the partially positive charge. In between them hydrogen bond. So this is also a hydrogen bond. Hydrogen bond. Even this one also a hydrogen bond. So this is the definition of hydrogen bond. So now let us write it. What is the definition? The attractive force developed between hydrogen atom of one molecule and more electronegative atom, mostly like nitrogen, oxygen, fluorine. These are the most electronegative atoms. More electronegative atom of another molecule is called hydrogen bond or hydrogen bonding. Right, this is the definition of hydrogen bonding. Then hydrogen bonding is a type, two types. There are two types of hydrogen bonding. Types of hydrogen bonding. Types of hydrogen bonding. So hydrogen bonding is two types. One is called as intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Intermolecular hydrogen bonding. The second one is intramolecular hydrogen bonding. One is intermolecular hydrogen bonding and the second one is intramolecular hydrogen bonding. First we will discuss about intermolecular hydrogen bonding. I am taking first intermolecular hydrogen bond. Intermolecular hydrogen bonding. So the term itself has a meaning inter means between the molecules. The hydrogen bond present between the molecules we have to call as intermolecular hydrogen bonding. So I am taking an example. This is example for intermolecular hydrogen bonding. So I am taking again HF molecule. This is the partial negative. This is the partially positive. Right? This is the partially positive here. This is the partially negative here. So this is one molecule and this is another molecule. So this is one molecule and this is another molecule. Both are two different molecules. Of course, the same type molecule, HF molecule only, but two molecules. So this is one molecule, this is another molecule. Between the two molecules, there is a hydrogen bond. The hydrogen bond developed between the two molecules is called as intermolecular hydrogen bonding. Even you can take one more example. What I am taking? Example one, this one. You can take another example is H2O molecule, water molecule. In water molecule I am taking HOH. So hydrogen is partially positive charge and oxygen is partially negative charge. I am taking oxygen, hydrogen. This is the partially positive, this is the partially positive, this is the partial negative. So this is one water molecule and this is another water molecule. Both are different water molecules. That means both are different molecules. This is a partially negative, partially positive, this is a partial negative. In between them hydrogen bond is developed. This one. This is a hydrogen bond. So the hydrogen bond develops between the molecules is called as intramolecular hydrogen bonding. So write the statement. The hydrogen bond formed between the molecules is called intermolecular hydrogen bonding. Intermolecular hydrogen bonding. I am writing intermolecular hydrogen bonding. This is the first category. Coming to the second category. The second one is intramolecular hydrogen bonding. Intramolecular hydrogen bonding. In the case of intramolecular hydrogen bonding, this develops between the molecule, but this is within the molecule. In the case of inter, the hydrogen bond present between the molecules. Intramolecular in the sense the hydrogen bonding present within the molecule. Example I am taking orthonitrophenol. So I am taking orthonitrophenol, N double bond O. This is nitro group and I am taking O, this is the H. Right, this hydrogen atom, this oxygen. This we have to call as a hydrogen bond. Hydrogen bond. So what is the difference? Understand? This is one molecule, this is another molecule. Hydrogen bond is there. This is one molecule, this is another molecule. Between them, hydrogen bond is there. But here is only one molecule. This total is only one molecule. Within the one molecule, hydrogen bond is there. That hydrogen bonding is called as intramolecular hydrogen bonding. Write the sentence. The hydrogen bond formed or present within the molecule is called intramolecular hydrogen bonding. Intramolecular hydrogen bonding. So this is the definition of intra, this is inter. That is the difference. So intra meaning is within the one, inter meaning is between the molecules. So this is hydrogen bonding. Next topic is coordinate covalent bond. The coordinate covalent bond is defined as the bond formed between two atoms by sharing of electron pair, which is contributed by one of the two atoms. Such type of bond is called as a coordinate covalent bond. Let us read the sentence. The bond formed between two atoms by sharing of electron pair, which is contributed by one of two atoms. One of two atoms is called coordinate covalent bond. Now let us understand what is the meaning of this statement by taking an example. I am taking an example of H3O plus formation. And if you take a water molecule, upon oxygen there is a pair of electrons, two pairs of electrons is there. This is one lone pair, this is another lone pair. And I am taking H plus. H plus in the sense it do not have any electrons. So hydrogen has only one electron, that electron is removed. So we will get H plus. That means H plus has a vacant orbital. 1s orbital is vacant. We removed electron. So vacant orbital. What is the electrons present on oxygen? This lone pair is donating to the oxygen. So donating to the hydrogen, to this atom. As a result, between the oxygen, this hydrogen also, already this oxygen is binds to hydrogens. And this oxygen again form the bond with this hydrogen also. So this bond is calling as a coordinate covalent bond. So what the molecule get is H3O plus. Now what is the point here is both are sharing, this oxygen and this hydrogen sharing the electron pair, but this electron pair is donated by only one atom. Only one atom is donating, both are sharing. One is donating, one is contributing, both are sharing. Such type of bond is called as a coordinate covalent bond. And you may got out what is the difference between the covalent bond and the coordinate covalent bond. In covalent bond, what are the atoms are participated in a bonding, both atoms contribute the electrons, both will share. I will take an example. I am taking H2 molecule. If you take H2 molecule, this hydrogen contribute one electron and this hydrogen, another hydrogen contribute one electron, both will share. This is contributing, this is also contributing, both are contributing, both are sharing. That is covalent bond. But hydrogen coordinate covalent bond is a special type of covalent bond. It is a special type of covalent bond. But what is the difference? One atom is donating, both are sharing. Here is both are contributing, both are sharing. Here is only one contribute, both will share. That is the difference. But it is also a it is a type of covalent bond. Coordinate covalent bond is a special category of covalent bond. Then take one more example, NH4 plus. NH4 plus. I am taking ammonia. In ammonia, upon nitrogen, there is a pair of electron. Here is we have one lone pair I am labeling as LP. And I am taking hydrogen H plus. It do not have any electron. The electron present on the nitrogen will be contributed to the hydrogen. And this nitrogen, this hydrogen share these electrons. Only this nitrogen is contributing, both are sharing. Then the product what you are getting is NH4 plus. So this is also an example of a coordinate covalent bond. So what is the difference? You have identified coordinate covalent bond, covalent bond. In covalent bond, both atoms are contributing electrons and both are sharing. But here is only one contributor, both will be shared. Such type of covalent bond is called as coordinate covalent bond. And coordinate covalent bond is also called as a dative bond. It is also called as a dative bond. So this is a coordinate covalent bond. With this, the chemical bonding chapter is completed. So this is the last topic in chemical bonding chapter. With this, chemical bonding chapter is completed. Thank you.